Hello everyone. Today I'm going to talk about microvascular networks automatic segmentation. My name is Xuechen Luo. Firstly, I want to talk the motivation of my project. There's a disease called sepsis. When people get infection, toxic event will appear in our blood and may generate blood clots. These clots will block blood flow and influence oxygen perfusion to surrounding tissue. Vasoactive medicine such as adrenaline and dopamine can treat sepsis. This medicine can increase the blood flow to break the blood clots. However, this medicine also has side effects on microvascular networks. Above all, both sepsis and its treatment medicine have influence on microvascular networks. For example, both of them can change the radius of vessel. Therefore, extract data from microvascular networks image is necessary for disease assessment and drug test. To extract data from video, firstly, we need intravitreal microscopy to record a video. Then we do image processing to have a binary image. Once we have binary image, we can extract data from the image, for example, the radius of vessel. And analyze the data from the video. So my summer work focused on the step of image processing. The equipment I used in my research is just a MATLAB. There are many ways to have good binary image from video. This summer, I tried two methods. Today, I use second method as an example to introduce the ongoing project. This method have two important steps. Firstly is apply red blood cells optical characteristics to achieve high contrast vasculature networks image. And the second is use scanning edge detection method to achieve automatic segmentation. So for the first step, how to have high contrast image? The answer is take a statistical calculation on video frames. Before I talk statistical calculation, I need to talk red blood cell optical characteristics first. Red blood cells have many pigments. Thus, only a few red light can pass through red blood cell. For a picture, red blood cell is darker than surrounding pixels because less light can pass them. This optical characteristic of red blood cell. This is the optical characteristics of red blood cell. Now I take mean image as an example to explain how statistical calculation to achieve high contrast image. At a specific time, we have frame one like this. And at another time, we have frame two like this. Okay. The darker points are red blood cell, and they are at different positions in different frames. if we add these two frames and divide by 2, we can have a new image like this. And so if we add thousands frames together and divide, we can have a picture like this. Oh, no. So then we can have a picture like this. I take this is original image, and this is a high contrast image. We can see this one have a higher contrast. And for this one, we can see just some dark points in the vessel. If we take a mean of all the frames, we can have higher contrast image. So if we have a high contrast image where it is easy for us to have the edge detection to generate the binary image. That's why we need a high contrast image. Okay, then I'm going to talk about Canarie method. So the process is here. We have a picture, and then we remove some noise, use Gaussian filter. And then we do first derivative of the image. And then for each pixel, we calculate by non-maximal suppression. And for each pixel, we perform hysteresis thresholding to make a finally binary image. I'm going to explain each step of Canarie method. For Gaussian filter, it's just used to decrease the influence of the noise in the picture. And then the first derivative. Let's see this graph first. At this point, oh no. At this point, gray value have a dramatic change. If I take a derivative of picture, we got a picture like this, the point is here. We have, if I take a derivative of picture, we have something like this. So point with dramatic gray value change is also a point with high gradient in first derivative picture. As the point here is have the highest gradient in the first derivative picture. Now I take a 2x2 matrix first derivative as an example. So it's something here. Because image is a 2D array, so we use we need to include a horizontal derivative and also a vertical derivative. So this gx gradient x is the horizontal derivative. It's just simple, like use the up right minus up left plus down right minus down left and divide by 2. Same as the gradient y is the vertical derivative. The same, it's just this one minus this one plus this one minus this one divided by 2. This is the derivative for image.